Hi, and welcome to Code Corner. This is a video series we do at Mayfield Renewables where we talk about codes and standards as they relate to the solar and energy storage industries. Today we're going to focus in on microgrids and Article 705 of the 2023 NEC. So in 705, towards the end of the article, there's stuff about microgrids, and we have done a couple other code corners on the topic already. And so if you haven't seen those, I encourage you to go take a look at those. They're, talk about the section in general. Today, I'm really going to focus in on microgrid interconnect devices. It's something our engineering team sees a fair amount, and it's something that we are working with and coming up with solutions to meet the requirements, meet customers' needs. And so that's what I want to focus in on, is looking at those. What are some of the most common ways that we do it, and what do those look like? So first, let's look at the actual code language. If you want to take a pause in the video to read this, I'm not going to read this language to you. You're more than able to, take a second, read through it. But what I really want to do is, point out we have these requirements for microgrid interconnect devices, and so we have some requirements for what those look like, how those are, and how we're going to implement those into our systems. At the very end there is that informational note saying, hey, sometimes these are actually incorporated into the inverters. That's not always the case. There are definitely some manufacturers out there that are doing it. Wonderful. It helps kind of take this part out of the equation for your engineering side. So when you're looking at those, that's wonderful and great. But when they are not, which what we are finding on larger commercial scale systems, less and less, or fewer, I should say, fewer of the systems have them incorporated than they actually do. So it's definitely something you need to understand with the equipment you've selected, how you're implementing it, how you're engineering it, and what that might look like for you. Just in a general sense, kind of setting the stage for where do these sit and what is going on here. We have this block diagram showing you, the major components, kind of how things fit relationally to everything. This is by no means an engineering drawing or single line drawing, but rather just kind of get you to see what those components look like and kind of how they all fit together. And what you'll see there is on the middle section, kind of towards the left-hand side, we have what we're calling the grid isolation device. That's our microgrid interconnect device. So this device can take a few different forms, and I'm going to show you those forms here in a minute. But what we need to do is we need to be able to isolate the utility grid from our microgrid in a way that we make sure that when the grid is gone, when the grid power goes out, that we are positively disconnected from the utility. This is a safety thing. We don't want to have our microgrid operating and still be connected to the utility, because then we could have the potential of backfeeding into the utility. This is like a well-known thing for PV systems. These are built into our PV only inverters. It's really simple. It's built into them. The grid goes away, the grid goes down, the PV inverter stops operating, no problem. With our microgrid systems, it becomes much more complex because we've added storage into the equation, and we absolutely want our systems to operate when the grid is gone. That's one of the big reasons why we do microgrid systems, is to back up loads. So you are up against having to find a grid isolation device. One of the things that I will mention is, we have our code requirements, and that's what we're focusing in on here right now. There's also going to be utility requirements. And so when you are proposing these systems, when you're going through the engineering and looking at the systems themselves, talking with the utility, understanding what their utility interconnection requirements are is really, really important. We've run across multiple AHJs, and we've run across multiple utilities that have differing requirements from each other, even sometimes neighboring. And so understanding this utility requires a isolation device that looks like this, and it disconnects these conductors, versus a different utility having a different set of requirements. So all to say, when you are going through this and going at the beginning process, this is a really big discussion to have with your utilities as part of that interconnection agreement, and that being able to make sure that you are meeting the needs, because once you go down the path, changing those becomes quite difficult, and if you don't understand what their rules are, it can get to be quite onerous to make those changes. So with our microgrid isolation devices, We are, as an engineering firm, we're seeing a lot, really two main ways. I'm not going to say these are the only ways, but the two main ways that we see these are with contactors and motorized breakers. So I'm going to show you both, and then at the end I'll flash a single line in front of you to show you kind of what it looks like in an engineering drawing. Contactors are devices where they are run by a PLC of some sort of control logic. So the microgrid controller very often will be doing this. You may see something that is a protective relay feature. And again, this gets into what the utility requires in order to make sure that you're isolating from the grid properly. So we have some way of isolating the utility from our microgrid system based on some logic. One of the main pieces of logic is the utility goes out of spec. The program, the controller, whether it's the PLC like we're showing here, or a microgrid controller, or a protective relay function, that senses this disturbance in the utility and opens the contactor. So we are isolating. So in this case, we would be isolating the utility from our microgrid. I'm showing a motor here, but hopefully you get the sense of we're using a contactor. We're making something that's making electrical contact, opening that electrical contact to positively break. It's a lot like a disconnect. We will see these very often in separate enclosures, having to be controlled again by some level of a controller depending on the exact type of system. And this may actually be a requirement by some ESS manufacturers. So we have seen some manufacturers out there, this is the way to isolate their systems, and understanding that is exactly how we need to handle this in order to provide that microgrid interconnect device, or that disconnect. So option number one is, well, I would say it's an option. I don't necessarily want to put them in a rank or anything like that. So an option is having this contactor to make that disconnect for you. Another option that we see quite often are motorized breakers. And these are, when you can use them, when they fit into the existing electrical gear that you have, this is a great option. Sometimes your disconnects or your main disconnects are already motorized. What I'm going to show you coming up is exactly that, where it's the main disconnect that is motorized to isolate it. And it really depends, again, on the system function. Are we backing up the entire facility? Are we just backing up a subset of it? So where this motorized breaker lives, how large it has to be, is it going in new or existing gear? All of those are questions that are very site specific. And so just knowing that using a motorized breaker that, again, is protected or is being connected to a microgrid controller or a protective relay function, in order to understand when the grid is in a state that is not okay to be connected. And then you can use that motorized breaker. One of the really nice things with the motorized breaker is it provides the overcurrent protection that you probably noticed in the code language that is a requirement for our microgrid interconnect devices. So it's kind of that all-in-one situation. Not always an option, both price-wise, being able to fit inside of the gear and all that kind of stuff. So, but it's a good option when you can use it. And so that's what I want to show you here with the single line. So this is just an excerpt of one of our single lines that we've put together. And what I want to bring to your attention there is kind of that main section, kind of in the center of everything that's going on in the drawing here. And you'll notice that we're calling out an SEL 751. That's a protective relay. So that is what's the logic behind this. It's looking at the utility. It's looking at what is going on with the microgrid. And you can see there it's connected to, right where it says main section, there's a 1200 amp breaker there, and that's a motorized breaker that we're using for isolation. So we are able to use that 751 from SEL to look at the state of the system, both the utility and the microgrid, and making some very real world, very split second decisions of when we need to open that breaker to isolate. So the beauty here is, again, we have a breaker. It's our main breaker for the entire system. When the utility, when it loses power or just goes out of spec, the SCL 751 will open that breaker for us, isolating the rest of the system from the utility, and allows our microgrid in this case to stay connected to and run the loads that are connected to it. So those are really the two options we see the most. And putting them into practice is one of the big things that you have to do. Putting the code into practice is what we're showing here. So thanks very much for joining this Code Corner. At Mayfield Renewables, we do a lot of education, a lot of training. We have online courses. We have our education summit that we do annually. So I encourage you to take a look at our website and see if there's a way that we might be able to help you with some more of your education around the solar and energy storage industries. And then finally, questions, comments. Is there another Code Corner you want to see? Is there a topic that you'd like to hear about? Or if you have specific questions about this or previous Code Corners, always enjoy getting feedback from people, hearing your questions. So here's a few ways to get a hold of us. Love to hear you and understand what you're looking for. And thank you very much for your time, and look forward to seeing you on the next Code Corner.